And in this paper, we talk about how to refine a pre-trained motion model. And there are two types of motions that we consider. The first type is optical flow, which are displacement vectors from one frame to the immediate next frame. And they can be considered as dense two-frame motions. Another type is multi-frames long-range tracking. And this is usually just a few trajectories on points we are interested in tracking, but spanning over multiple frames. Labeling these motions is very hard on videos and is much more difficult compared with 2D images. The main reason is the density of the motion, that there could be many unique tracks from the video. Therefore, state-of-the-art motion estimation models are usually trained on synthetic data. I need to combat a simulation to real gap. There are some self-supervised methods, but they mostly focus on training the motion model from scratch and perform much worse than the state-of-the-art supervised methods. And if we aim to improve the performance of the pre-trained model on the target domain using these self-supervised techniques, we find that they consistently make the performance even worse. We assume that this might be because the self-supervised training signals are too noisy and just mess up the pre-trained weights. In our method, we focus on obtaining clean training signals from unlabeled videos. We first run the pre-trained motion model on an unlabeled video to generate some motion estimates. And then we design a cycle consistency-based filter to filter those estimates down to good trajectories. Specifically, cycle consistency assumes that if for a good track, we track forwards in time and then start at the end point and track backwards in time, we should end up at the original start point. In the next stage, we perform some augmentations on those good estimates and fine-tune the pre-trained model to reproduce those estimations. Compared with other self-supervised techniques, our proposed framework is the only one that reduces error of a pre-trained model. For example, here we are able to bring down the error of a pre-trained rough model by 10% with our self-supervised fine-tuning. And these are some visualizations of the motion estimates produced by our method. As you can see, our method refines the optical flows by completing missing objects and cleaning noisy tracks. And here are some more visualization. On multi-frame tracking, we also bring improvement. Here we can see that tracking a point on the background, the original tracker is stuck on the car while ours fix this error. Here, the pre-trained tracker gets completely lost while our method keeps the trajectory to the end. And here, the original tracker is stuck on a person while we continue to follow the dog.